Today we are looking at simulation analysis. I think this is the last chapter under operational research for our unit this semester. And simulation analysis is a very wide area, but we are only narrowing down to look at what we call Monte Carlo kind of simulation analysis in this particular unit. So that's the only thing we shall be looking at in this particular lesson. So we want to briefly just try to understand what simulation analysis is about, the different simulation models, the uses, the steps, and we are going to engage ourselves in, with 3 practical examples of how we can use simulation analysis to model a real life situation in business or event. So majorly the 2 objectives to apply simulation techniques in solving some business problems. And because you're going to narrow down to Monte Carlo simulation, which involves random numbers, we want to see how we can actually obtain random numbers, then use them to generate observations for some given variables. So the word simulation comes from the word simulate. And to simulate means just to imitate. Can actually be interpreted as to imitate a real situation, a real event, and so on. If I make a toy, if a child plays with a toy of a car is imitating just the real car. So it's a real car. So it says imitating. So to simulate is to try to duplicate the features, appearance, and characteristics of a real system. And so in this case, we want to mimic a real life, maybe business problem, particularly if it's a business that you want to venture in or an investment you want to venture in. So through simulation, you want to mimic it and try to maybe just try to kind of assess its viability prior to actually just making a decision to venture into it. And so we are going to do this by way of expressing it mathematically, then study the properties, operating characteristics of that venture, and then finally draw conclusions and make decisions whether to, based on those simulation results. I think through the 3 examples, practical examples, you shall be able to appreciate more when we are talking of simulation. So we make use of simulation, of course, for reasons when maybe other techniques, maybe trying to assess the feasibility and viability of that venture are not applied. So I've defined simulation modeling here, but here I'm defining simulation modeling in the context of this type of Monte Carlo simulation analysis. That this is one that involves making decisions by use of random numbers. We are going to see how to create those random numbers. So the 3 types of simulation models for simulation analysis, we have the Monte Carlo simulation, which is going to be our thing for this lesson. And you have said this one involves probabilities or chance. So each outcome of a variable will be given some probabilities. But we also have what we call another form of simulation analysis or simulation models, which is called operational gaming or game theory. And this mostly involves competition of 2 or more competing players. And we also have system simulation for large systems. So for us, we are narrowing down to this particular one, first one, in this particular unit. So when I'm mentioning uses, I'm giving uses of general simulation. The uses of simulation analysis include evaluating alternative investment projects, determining optimum inventory level, determining stocks requirement, determining optimum number of facilities in a complex sequence. So simulation analysis, you may find that is cutting across even a number of the other techniques of operational research that we have looked at. And so we shall look at problems, different problems, and try to figure out. Now, what are the steps that we need to follow when you're using Monte Carlo simulation? So Monte Carlo simulation, for us to simulate a process or to imitate an event, we have to follow these steps. One step is we shall be determining probability of each outcome. This, in most cases, most of the problems you have for this, you may be given those probabilities, or you may be needed to research on those probabilities. Then once you have gotten the probabilities of each outcome, we shall be creating what we call the cumulative probabilities. We determine cumulative probabilities with the once the probabilities of each outcome are given, it's easy to compute now the cumulative probabilities. And we are computing them just the same way we compute cumulative frequencies given frequencies. Then we shall do what we call, we shall use those cumulative probabilities now to determine the range of random numbers. The range of random numbers. So random numbers, the range of random numbers can only be created with using cumulative probabilities. And then the next thing we shall be now identifying where the random numbers are feasible in the random numbers generated from the cumulative probabilities. So the random numbers in all problems you are going to work with, we shall be given those random numbers. And so those random numbers, we shall now be checking them in the range, using the range of numbers we have created. We shall be trying to identify where they're feasible, maybe with a given problem. And then in most cases, we should be creating what we call a working sheet. And the working sheet will now be consisting all the variables, the random numbers, and maybe will also be consisting of optimal solution as one of the columns. So we shall see with an example how to create a working sheet with all those variables and random numbers. And then, of course, determining the optimum solution. The optimum solution could be maybe determining the average profit or determining the whatever outcome of interest, could be even the total revenue and so on. So maybe before we look at those practical examples, we need to understand, first of all, how to calculate or create random number ranges. As we have seen, the procedure for us to be able to apply simulation properly, particularly this Monte Carlo simulation, we have said that we are going to have some. So these are variables. You can have a variable like price, and probability for each of the outcome of price. You can see the price here has 3 outcomes, 20, 25, 35, and the probabilities for each of those outcomes are given. So from those probabilities, then we can create the cumulative probability. Then with the cumulative probability, we can create the random number range. We have said the random number range must be created before we are able to carry out the simulation analysis. And so in simulation, this could be the prices maybe of existing product. It could be, let me talk of maybe this is a bus of maybe costing this much in one shop, this one another shop, and this one's another shop. And you're trying maybe to determine the price of a bus shop. Maybe you want to set up also a shop for that matter. And so you want to check what the prices of the markets, and also look at the shops that sell maybe at a price of 20. The proportion of those shops is maybe 0.3, or 30% shops sell at that price, 40% shops sell at that price, and 30% shops maybe sell at that price. And you want now to set up yours, or to venture into that business of selling bus shops. And you may want to just determine the price you want to set. So this could be now a simulation kind of model. So how do we create the random number range? So the random number range, you have said, we first of all create the cumulative probabilities, and we are doing them just like we do the cumulative frequencies. But even before you begin getting the cumulative probabilities, it is paramount, first of all, to check that the sum of the probabilities of all those outcomes is actually 1, because you can have scenarios where maybe probabilities here are not summing up to 1. Remember, all the outcomes form the entire sample space, probability sample space. And so you expect that the sum of the probabilities sum to 1. So just check whether 0.3, 0.1, 0.3 sum to 1 before you even begin working out. Sometimes could be an error. So if it's not summing up to 1, then that could be an alarm to raise. Like in this case, the probabilities here sum to 1, so we have no problem, we can begin. So the first cumulative probability would just be the same as the probability of the first outcome. And so we keep on adding downwards. So the next cumulative probability will be 0.3 plus 0.4, and this will give us 0.7. And the next cumulative probability will now be the 0.7 plus 0.3, and that gives us 1.0. And so that's how we calculate the cumulative probabilities. The bigger task now comes in when you are finding the random number range. So for the random number range, this is what I will say, that first, you need to, we treat these cumulative probabilities as whole numbers, assuming decimals are not there. Whenever we want to create the random number range, treat them as whole numbers, so that you're talking of this as just 3, 7, and 10. So once you have treated them as whole numbers, now the upper limits of this range, because when you talk of random number range, is an interval from a particular lower limit to a particular upper limit. So the upper limit here will now be, you now less 1. 3 less 1 is 2. 7 less 1 is 6. 10 less 1 is 9. That's it. When you use the upper limits of these assumed cumulative probabilities to be whole numbers, you get those upper limits. Now the lower limit will definitely now be, this will be 0 to 2. Now, because you want to make it continuous, the way you do statistics, and you're creating a continuous variable, 0 to 2, then this will be there for 3 to 6, then this will be now 6, 7 to 9. So this will be the random number range. In fact, if you check my hashtag in my first statement here, which I first of all omitted, I said that when the cumulative probabilities are in 1 decimal place, when the cumulative probabilities are in 1 decimal place, then we expect the range of numbers to lie from 0 to 9, such that 0 will be the first one and 9 will be the last one in the last outcome. So they will be between 0 and 9. But we can also have scenarios where the cumulative probabilities are in 2 decimal places, like the example you're going to just have next in computing the range of random numbers. And you're going to see that the first, the range of random numbers will begin from 0, 0, and the end will be 9. So maybe we look at that, then we see whether there's somebody with a question or a query to ask. Now again, I've used just the same variable price and the same 3 outcomes, but I've then changed the probabilities. Let's say this is 0.23, this is 0.46, this is 0.31. I assume that these ones add up to 1 as well. This is 0. This is what? Yeah, this is what adds up to 1. So the cumulative probabilities here, you'll have 0.23. Now 0.23 plus 0.46 gives us, that should be 9, 6, 0. And then now 0.69 plus 0.31, that gives us 1.00 as the cumulative probability. All of us can appreciate or can see clearly that this time round for this particular problem, the cumulative probabilities are in 2 decimal places and not like the previous example where the probabilities were in 1 decimal place. And so we said that for you to compute the range of the random numbers, we begin by assuming that the cumulative probabilities are all numbers. So we assume that this is actually now 23. Okay. Let's assume this is 23, and therefore the upper limit, you are lessing 1, 22. This is 69, the upper limit, you less 1, 68. This is 100 if you have assumed the decimal number, so the upper limit is 99. And so we are expecting, of course, from 00, 22, then now next 23 to 68, then next 69 to 99. So this will be the range of random numbers for this kind of problem. You can see again, I had emphasized that when the cumulative probabilities are in two decimal places, then the range of the random numbers will begin from 00 and end at 99. And you have seen that coming up clearly in this particular second exam. Are we okay up to that stage?
Yes.
Yes.
It is clear, yes.
Thank you. So let's begin by looking at the practical examples I want us to look at, so that then we even appreciate maybe what this concept is all about. I'll ask that maybe we copy this table first. Just copy the table only, because I'll be sharing. I've already shared these slides even in our virtual campus. So just copy these slides for purposes of trying just to move together before we begin discussing it. Are we through?
Yes.
All right, thank you. I've just checked even this first table. I think this one doesn't add up to, the probabilities here don't add up to 1. 0.15 plus 0.42 plus this. Maybe we check this to 0.30. See, this one is not adding up to 1. Huh? I don't know whether you have observed that. Yeah, these probabilities ought to add up to 1. This one ought also to add up to 1 huh? Before we proceed. So please rectify that. I think if we do that, then they are adding up to 1. And so this is an example where they're talking of a company has a number of potential films and is considering producing. This company is considering producing these films. And so the expected revenue and costs from the film in million Kenya shillings have been estimated. So, for example, the expected revenue of about 254 million Kenya shillings, that proportion, that chance of getting this revenue is 30%. The chance of getting to 54 million Kenya shillings as revenue is that. The chance of getting 318 million Kenya shillings is 42%. And the chance of getting this is actually 28%. But there are also chances of the expected costs to be spent to get the given revenue, like the chance of spending to 48 million shillings is actually at 25%, 26 is 42%, and 272 is 33%. And so ideally, that is what you have. These other two columns, I've just created them for purposes of working. But actually, the question would only have a table of just the variables. So there are two variables, revenue and cost. Each variable has three outcomes. Each variable has three outcomes. And so the question could be this way. Use simulation method to find the average profit, under 5 different circumstances. You may use random numbers given below for the revenue and costs. So you want to determine the average profit. Now, if you have revenue and you have costs, then you all agree with me that the profit will just be revenue minus cost. But then how do we go about this? So the first thing we need to do is let's get the cumulative probabilities for each of the variable for revenue and cost. Let's calculate first of all the random number range for revenue and cost. Then from there we shall create a working sheet. That working sheet will now have the random numbers. We have been told these random numbers are for revenue and cost. And so if they're talking of 5 of them, they're talking of 5 pairs because you're talking of 2 variables. So this should be 5 pairs, 1, 2, 3, 4, 5. So revenue and cost, it means 98 represents revenue, 12 represents cost, 56 represents revenue, 02 represents cost, 38 represents revenue. So that's how they appear in pairs for those. So when they are talking of 5 trials or 5 circumstances or 5 runs, they are talking of pairs because you have 2 variables here that we must have. That's why you can see the number of outcomes here for revenue is also equal to the number of outcomes here for cost, so that then when you're even calculating the profit, we get the profit per outcome. Then we are able to sum and maybe get the average at the end of it all. So maybe quickly we begin by creating the cumulative probabilities for these 2 variables before we begin discussing. So let's fill these 2 columns, the cumulative probability and the random number range, maybe quickly. Are we done?
Yes.
Yes.
All right. So we need just to confirm this should be 0.30, 0.72, then 1.00. So you're talking of 00 to 29, 30 to 71, then 72 to 99. In agreement?
Yes.
Thank you.
Yes.
Then this other one is 0.25. Plus this is 7, 6. And then I'll have 1.00. So I'll have 00 to 4. Then 25 to 66. Then I'll have 67 to 99. Good. So if that's okay, now we need to create a working sheet. Now the working sheet will be this format. So you'll have a working sheet that a working sheet should have those columns. You'll have the trials. In this case, we are talking of 5 different trials or circumstances. So just number them 1, 2, 3, 4, 5. And then you now have the random number, the first random number for which variable? The first variable is revenue. So revenue. Then so revenue, but you write the random number associated with it first. Then you'll also have the random number associated with costs. Then you can now have something to do with the profit as the last thing, because you want to find the profit. So that now the random numbers, let me just try to move this slightly up. So the way we have paired them up, so 98 comes here, then 12 is the first one for cost, the random number for cost. I don't know whether we see that. We are filling in that this is a working sheet. Then the next one I'm talking of, the second trial circumstances 56 is the random number for revenue. And then 02 is the random number for cost. Are we following?
Yes.
Yes.
No.
Yes. We are not, huh?
Yes.
Can you repeat?
Kindly repeat.
Yes. So we are saying we are creating a working sheet, and the working sheet is guided by the variables that we have in the question. So in the question, we have two variables. There's the revenue and there is cost. So we are going to have a column for revenue. We are going to have a column for cost. And now they have given us some random numbers associated with revenue and random numbers associated with cost. So the random numbers associated with the revenue, that's why you can see I'm writing random number before it. And for cost, also random number. So those are like 4 columns now. And so why I've created an extra one at the end of it all is because eventually the question wants us to find the average profit. That's why I've created another column for profit. But these two random numbers are the ones given at the end of the question down here. And so when we have two variables, then it means these values, you need to pair them up. They're usually paired up, and therefore, and they are arranged according to the first variable given in the question is revenue. So that first digit represents revenue. Then the second number represents now cost, because cost is the second variable in the question. So now that's why you can see I've written letters in alternatingly R, C, R, C, R, C. So you can now begin even picking the R. The R is 98, 56, 38, 17, 63. So those are the ones going to be among the column of random numbers associated with revenue. So you have 98, 56, then you have 38, 17, and finally 63. So the other ones, 12, 02, 66, 55, 98, are now the random numbers associated with the cost. Leave this column of revenue blank. Leave this column of cost blank. Just fill in the ones with the random numbers first. And you're talking of 5 different circumstances, because you can see these are 5 pairs, which I'm calling trials as well. I think that's now clearer.
Yes.
So let's fill in those 2 columns. So you should be having the first one this way, right? So we have said for the random number for cost is 1202, and then what do we have?
66.
66,
66,
55,
55,
98.
8. Yes. So those are there are 5 trials. Now we need, using simulation, what we are now looking at, we now go to the table of, we want to fill this column for revenue first. And for us to fill that column for revenue, we now go back and use this table for revenue, the range of random numbers we have created under revenue. So we are making use of this first table to fill that column of revenue in that question. Now, in this particular question, now you're checking a random number of 98. You need to tell what revenue is likely to fetch a random number of 98. And so you come now in this table of revenue and check. If the first column is 00 to 29, the random number here 30 to 71, 72 to 99, you will see 98. 98 is actually in this last range, class interval of 72 to 99. And so 98 corresponds to which revenue? 1382. So we now write 1382 as the revenue here. Then we got the next one. The next random number given is 56. And we now check again that table where 56 is likely to lie. Which class will it lie? 56 is actually here, between this list of 30 to 71. And here the revenue that is likely to be fetched is 318. So we fill 318 as the revenue under this. Do you see that?
Yes.
Hello?
Yes,
Now,
Mwalimu.
now let's complete that column. Let's complete that column, then we compare. Let's complete that column, then we compare. So what do you have? 38 corresponds to what revenue?
318.
318
318, thank you. 17,
to 54.
54, and 63,
318.
318.
318, thank you. Now, when we want now to determine the cost, now we use now the table of random numbers for cost. Now we use now this table for cost. So that costs are either 248, 260, or 272. Like for example, the first figure is 12. Is it 12? Yes. So we check 12 corresponds to 248. Is between 0 and 24. So you have 248 as a figure that you actually plug in here. We see that? So let's fill also that
Yes.
column for cost. Let's complete this column as well. So you can have the feedback for 02,
248.
248,
260.
66 is
260.
260.
260, yeah?
Yes.
And then 55,
260 again.
260 as well, and 98,
72.
272.
272, yeah?
Yes.
Yes.
Good. Now for profit, now we need this column for revenue and cost, because there's no any other figure you've been told. So profit here is just going to be revenue minus cost. So 13 minus 1882 minus 248.
1334.
Yes,
1334.
1134.
is 1134. Huh?
No.
May not be 13. Yes.
Yeah, it's 1134.
Thank you. 318 minus 248.
70.
70. 318 minus 260.
58.
58. And then 254 minus 260. Minus
Negative
6. And 318 minus 272.
46.
46. Good. So we can even get the total profit. So the total profit, we add the profit from these 5 trials. So when we sum all this, what do we get?
$1302.
Yes,
1302.
1302, yeah? Now, the question requires us to find the average profit. That is the total profit for those 5 trials. So the average profit should be now the profit for the 5 trials divided by the number of trials. Huh? So that will be 1302 divided by 5. Average profit. 1302 divided by 5. They are talking of million Kenya shillings. So this gives us
260.4.
60.5. Okay, those are the million Kenyan shillings now. That will be now the average profit. We're using those 5 trials. And so maybe from that figure, one now can figure out whether investing maybe in that film industry is worthwhile. Yeah, so that's how you now use simulation in that kind of case. I want us to look at another practical example where we are using simulation and particularly just generating random numbers and trying to solve a question and see how it does. So there's a company in the production of a new product. The new product, they are calling it Innovator. We are told there is a fixed cost of production estimated at 4 million. And you are told the data below relate to the probability distribution of the selling price, variable cost, and annual sales volume. So that means you now have 3 variables: the selling price, the variable cost, and annual sales volume given down here. And so you can see each of those variables has 3 outcomes. Each of those variables has 3 outcomes. And they have given us the probabilities for each of those outcomes. So the question, of course, would just be again, kind of maybe profit. So simulate the average profit. Again, we want to find the average profit on the basis of 9 trials. Now here we are talking of 3 variables. It means we are talking of 3 variables, so 9 of them. Huh? This should be, so you talk of 9 pairs and each pair should have about 3 of these values. So those are 9 pairs because you're using 9 trials, using random numbers given below. So that now in this case, again, just like we have been doing, the first variable is to do with selling price. We may denote it with P, and this is variable cost. We may call it V. And lastly, we have annual sales volume, can call it X. So I'm talking of this is P being P, V, X, P, V, X, P, V, X, and so on and so on and so on. So that when you should be creating now that working sheet, it becomes easier for you now to assign those random numbers in that table accordingly. So maybe we draw this first, and of course we need to add two more columns, one for cumulative probabilities and another one for the random number range. We need to have those two. Cumulative probabilities and the random number range. So let's do this first one first before I display the next slide.
Madam, scroll it up.
You done? I scroll
The
down a bit.
Yes.
annual sales volume.
I'm assuming you have even computed those figures in those two columns. So maybe you give me the results. So this was 0.17,
0.65.
0.65, 1.00. So you have this as
16.
0 to 16,
16,
19 to
64,
64, 65 to
65, 99.
Then the other one is 0 to 3,
087.
087
087,
and 00
So we have 0 to 22,
22,
3 to
23
86,
to 86,
87.
87 to 99.
All right, that's good. Can check the next table. So the next table we have 016,
0.4,
0, 100,
0 to 15,
then 00 to 15,
16 to
16 to
39,
39,
40 to 99.
99. Good. So we create a working sheet where we are having, first of all, trials 1, 2, 3, all the way to 9. Then we begin the random number of the first variable, which we said was a price. So we have 81. Oh, I think we have not done it this. We can begin doing this. So price, and then we have the random number for which variable next was what? Was variable cost. Huh?
Yes.
This was variable cost. I had called it V. Then we have the random number now for whatever I've called as units sold. And this time we should also need to get profit. Now, how do we get profit, first of all, even before you begin? Profit here may not be like revenue minus cost like in the previous example. When we have the variable cost, the selling price, and the units sold, how do we find profit in this scenario? How do you find profit in this scenario? That's not simulation, because it's something I think, a concept I think all of us should be aware by now. How do you find profit in that case? We have
It should be
yes,
sales are, oh, okay, profit is equal to annual sales
yes,
minus fixed cost.
minus fixed cost. Oh, there's a fixed cost, huh?
Yeah, yes, I think there was a fixed cost
Yeah, there's
somewhere.
a fixed cost.
Plus variable cost.
Plus variable costs.
Mhm.
And the units.
And the selling price is it.
How do you find
Just a minute.
profit?
Mhm.
Mwalimu,
Yes,
you're going to take the annual sales in units, you multiply
yes,
by the selling price of that, the one that is up there. Now
yes,
you
so
get the sale.
that's
After you
PX.
get, yes, after you get the sales, now you're going to less, now the sales in, I think it's in shillings, now you're going to less the fixed cost and the variable cost.
So this is again VX. Then you minus the profit. So we can just say profit is P minus V. Then that difference now times X. Then we are talking of fixed cost. I gave you a value of what? Fixed cost of production is 4 million now. Yeah, so we minus that fixed cost, right? So this is what is going to be the profit equal to. Good. Now let's begin first of all now creating a worksheet so that we fill in. So let's create a worksheet with the trials, random number. Then we have, this is the selling price, random number. We have the variable cost, random number. Then we have the annual sales volume or number of units. Let's fill those columns. So the first one here I said is going to be 81. Then we have 604. Then we have 62. All the way to 82, yeah? Are we in agreement that first column?
Yeah.
Yes, yes, yes. Thank you. Now let's, we can leave this column for price first of all on hold so that we also fill the random numbers for the variable cost. So for the variable cost, you're beginning with the random number 32. The next one being 46. This one should go all the way to, the last one should be 89, right?
Yeah.
Yes.
Yes, yes. Thank you. Then we have the random number for this annual sales. The first one is 60. The next one is 31. And the last one should be 25. Huh?
Yes.
So we now need to, first of all, begin now filling in the columns P, V, and X.
Yes.
So we check 81 using the random numbers created by that table for selling price and check where 81 lies. So when you check 81, that random number 81 is in this particular class, which corresponds to a selling price of 500. So we write 500 down there. That's okay?
Yes, that's okay.
Yeah, so let's fill in that column. Let's fill the entire column. So the last one, just to be sure that we are okay. Are we still having 500?
Yes.
Thank you. So we can now go to the second one. Use the second table now for variable cost so that you're able now to predict the variable cost when the random number is, say, 32. So when it's 32, what is that variable cost?
200.
200.
Thank you. When it's 46,
It's also 200.
200. So let's fill the entire so that I'm interested in knowing the last one. When it's 89.
300.
300.
Good. So we are already done. Huh? Then we go for the last one when it is 60. What will be the sales units? 40,000.
40,000. Yeah.
We have when it is 31, it's 30,000. and so on. So let's see when it is
25,000.
Still again, 30,000. Good. So at least we are seeing how we are getting those. Now we want to get the profit per each trial. So we need the profit. Now it's just P minus B times X minus a fixed value. This fixed value is 4 million. So we are just picking the P here, 500 minus 200. That gives us 300. Then times X, 40,000. Then minus 4 million. So that's the figure that we need to write here. Which figure are you getting?
8 million.
Yes? You have gotten? Somebody was shouting an answer.
$8 million.
It's 8 million, huh? The rest is good just to confirm. I have no solution for this question, so that's why I want us to confirm that.
Yes, it's 8 million.
Thank you. Then the second trial, we are now talking of, I don't have a figure here for P, minus 200, then times 30,000, whatever you get, minus 4 million as a fixed cost. What do we get?
Loss of 1 million.
Yes,
A loss of 1 million.
a loss of 4 million. Thank you.
Loss of 1 million.
1 million.
Is one, not four? Huh?
Yes.
Okay. So we can fill that.
A loss of 1 million.
Okay, that's okay. So you can fill the entire column so that I want to hear now the last iteration. So the last iteration, what do we have?
2 million.
2 million, huh? So we can now get the total profit by summing all those. And so in this question, we also want to get the average profit. So that total profit divided by the number of trials, 9 of them. So you can just give us the figure for the average profit.
$15 million.
The average profit is 15 million. Huh?
Yes.
And a second.
May I have a different answer?
The average profit is what from your end?
1 million. Yeah, 1 million with a lot of triple fours, 0.4. 1, then 6 fours, 0.4.
Any other different answer from the? It's good to try so that we share the feedback. But we vote who could be the correct one.
It is 2 million.
You're getting a profit of 2 million, average profit.
Yes. No.
2 million.
Okay.
A profit of
Yes.
18 million.
So divided by 9, you get 2 million average.
And average is of 2 million.
Why? Sasa, how do I tell who is correct and who is wrong? Probably maybe you see if we make a mistake inside here, Maybe let's get that last column. Maybe we see where we are not getting all of us correct. The first value for first trial, the profit was 8 million. The second one is a loss of 1 million. The third one is what?
2 million.
2 million profit. Huh?
Yes.
The fourth,
2 million loss.
2 million as well. The fifth,
What is negative 1 million?
that's a loss of 1 million. This sixth,
Mm-mm.
4 million.
the sixth is 4 million. Huh? The seventh,
Hey, Marim, the second 2 million is a loss.
this one here.
Yeah, yes.
Okay. So get me the seventh trial. The profit for the seventh trial.
There's no profit, that's a zero.
It's a 0.
It's a 0, yeah?
Yeah,
Yeah.
And then the eighth,
a zero.
a 0 as well. Then the 9,
2 million.
2 million.
Then Mwalimu on the fifth one, the fifth
Yeah.
trial.
On the fifth
0.
one,
Yes, the fifth trial.
this is 1, 2, 3, 4. This 1 million, a loss of 1 million.
It's 0.
It's zero.
It is 0, not this, huh?
Yeah,
Yeah.
because
Okay. So probably that is where maybe some of us made a mistake. So this one and this one cancels. This 4, 12, this is 11.
mhm,
11 million plus 2, so you are getting 13 million total. Huh?
yes, 13, yeah. Then now you divide that by
The
9.
profit, this divided by 9. So the average profit is now what?
1,404,000 for another 4.
One, four, 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 four,
It's an
6
estimated
4.
figure.
Yeah.
Can we check trial 8?
Trial?
Trial 8.
Trial 8, they told me 0.
Yes, because you have selling 300 minus 200, that's 100. And you have 400 for 40,000 units.
Oh, if you check selling price,
30,000.
Trial it is 2 million.
What is the selling price for trial 9 here?
30,000.
Yes,
selling price is 400.
it's 400. What's the random number?
31.
31.
31.
31. Oh, yes, I see.
31.
Yes,
Yes.
which is 400.
100.
So it's
So are we getting the profit to be 0?
no, the profit
No,
is
it
2
is
million.
4,000. It's 4 million, not 2 million. It's
2
4
million.
million.
2 million.
No.
2
It is 4
million, Mwalimu.
million.
Then you less the fixed cost, it's 2.
4 minus 200 times
It's
30,000.
200.
Yeah.
Times 30,000.
Not
And then
that,
that
not
is 6 million.
30,000. If you
The
go
good thing,
to column,
40,000.
Yes.
if you go to column for random variable for
X.
units,
Okay.
yes,
Mingapi, 68.
Yes. Yeah, okay. Okay.
It's
68
30,000.
is 40,000 units. So if you multiply 200 by 40, it's 8. 8 million minus
Yes.
4 million is 4 million. Yes.
All right.
I see. Yes,
8 million minus. Yes.
thank you for that. So what do I write as a total profit now? Or the average profit? In fact, just give me the average profit now. So you realize that if you make an error when you are creating those random numbers, then you'll definitely affect the
Our profit
outcome.
is 17 million.
That's total, huh?
Yes.
Mhm. And then the average divided by
So we will be
9,
having, it will be having 1.8.
around 1.8 million. Huh?
Yeah.
That's okay. At least, even if you are not at 1.8, most of us have gotten the idea of what to do. So maybe it's just a mistake of omission, or not being keen when you're filling those columns. That is resulting maybe in these small mistakes. Huh? So we need to be keen a bit when you're using those tables of random numbers. So you're okay. Good. So that's how you compute using
So-
that. Maybe one last example. And this is a question. Okay. One last example. Sometimes those probabilities may not be given in a question directly, but then it's a question of simulation, like this example I'm just highlighting, where they are telling you the price of a soap is actually given as 360, and the cost of producing that soap is actually 200. But then you are told that the table below shows the buying of soaps. Let me mute you all for now. So that we have fewer participants. Anyway, so we have a table here showing the buying of soaps from a shop on a weekly basis. So maybe 6 soaps are bought maybe for a period of 9 weeks. 8 soaps have been bought for a period of 19 weeks. 12 soaps have been bought for a period of 10 weeks. 14 period of that. 17 soaps have been bought for a period of 4 weeks. And so the question now comes, simulate the following random numbers and find the mean contribution margin. The mean contribution margin. So we have these random numbers. So that means we need to create again, we need a table of random numbers. And that table of random numbers, now we are doing this. So you have your soaps here, 6, 8, 12, 17, as shown in the previous table. Now the weeks here is representing the frequency. How many times 6 soaps have been bought? And the times is in terms of the number of weeks. Is in terms of the number of weeks. So we are seeing like, we have said that 6 soaps have been bought for 9 weeks. So this is a frequency. 8 have been bought for 19 weeks. So this becomes a frequency which we add gives us 50. And so no one will tell you this is a frequency, but then means you need to figure out that this is actually the frequency of being of this item being bought. This is a frequency. So you sum these frequencies, which is giving you 50, and then now you get the proportion. The proportion will be now the relative frequency of each of those. Huh? So like 9 over 50 gives us 0.18. 19 over 50 gives us 0.38. 10 over 50 gives us 0.2. 8 over 50 gives us that. 4 over 50 gives us that. So this relative frequency will now be serving us the proportion. So that we are saying that the chances of buying 6 soaps is 0.18. The chances of buying 8 soaps is 0.38. The chances of buying 12 soaps is actually that. And so from this, now we are able to create the cumulative probabilities or the cumulative relative frequencies in this case. The 0.18 plus 0.38 to give you this, then plus that until you get 1. Then from here, you can see the relative frequencies. The cumulative probabilities are 2 decimal places. So you can now get the relative number range just like you have been doing. So this is 00 to 17, then 18 to 55, 56 to 75, 76 to 91, all the way. So it's a unique kind of question, so that once you have this now, with the random numbers given now, you may want to create a working sheet. So the working sheet now would be a bit tricky here. So you're creating a working sheet for SOPs. Because you're now going to have a random numbers. You may want to arrange these random numbers. Maybe you can arrange them column, or they can even remain the way they are. So you have 06, you have 33. There's only one variable, so you don't need to you have 99, you have 86, you have 45, you have 68, 79, all the way, all of them. And now you are using that, the first one is 06. Huh? So you check, let's say this 06. 06, you check against this random number. And you see now 06 here lies within that first interval where the number of SOPs being bought is 6. And so you now write that, because here you have the column SOPs. Now you have this now given as 6. Then you check 33, the random number given 33, that's the next random number. That's the next random number, 33. And then you check again 33 now within this range will actually lie between 18 to 55. And 18 to 55 corresponds to the number of SOPs being bought being 8. So the 8 comes here. Then you check the next one is 99. Now 99 now, see 99 is here. So corresponds to the number of SOPs being bought being 17. So 17 comes here. And so you do all that for all this. Then of course you now even get the sum. You even get the sum of SOPs being bought. And so if you want to get the mean, you can now get, so if the SOPs are being bought at a particular price, each SOP, and the cost of producing, you can now calculate. So I've created that, though I didn't create a column, but those 6, 8, 17, these are the figures we are adding. When we add all this, when the mean we divide by 18 of them, there are 18 random numbers. So it's giving you 10.22 as the mean number of SOPs bought. The mean number of SOPs bought. So if we want to get the mean contribution, we have said that now it's like just getting the average profit, because each SOP is being sold at this, and each SOP, the cost of production is this. So this difference is actually giving us a profit per piece. And so if this is the average number of SOPs, then the total profit will just be piece times the piece, and that gives us that. So the emphasis here is that sometimes they can give you a table of items and frequencies, and you may want to wonder now, how do I get probabilities? The relative frequencies will actually be representing probabilities of completions. And so you use those ones now to compute the range of random numbers for the given items before you're able to carry out your simulation. So that's what that example is all about. And so that is what we need to know under simulation analysis as far as the course outline is concerned. I don't know whether anyone of us has a question.